So we're now in the Flight's Reactive Microservices project in my IntelliJ IDE. And we're going to go ahead and take a look at the source for the reactive implementation of the Flight's microservices app. You'll see, as usual, as is always the case, we have a main folder that has all the source code and the resources. And we also have kind of a sibling folder called test that has a whole bunch of mocked regression tests that test various features to make sure things are working properly. Let's go ahead and poke down here. This has really got very much the same package layout that we've had for the other implementations. The main difference, of course, is that this one is using reactive programming features with Project Reactor. And it's also like the functional version we looked at before, using approaches based on the microservices-based approach. So let's go ahead and take a look first at Flight. So Flight is what we call basically the API gateway. It's kind of the API that's exposed to clients. So if we have a client running here, which could be a browser, it could be Postman, it could be an Android app, whatever you want it to be, it can go ahead and access this through this particular application. The application is pretty much like what we always do. We have an application with a main method that's going to run this as a Spring application. And you can see we have a bunch of annotations here indicating this is a Spring Boot application. Surprise, surprise. We're going to have a flag here that says enable discovery client false. We don't want to have this particular guide be a discovery client because it's the API gateway. You'll see the other microservices we have, we want to have them be part of the discovery client capability. And then we also indicate where to find the properties for this particular thing. And that's down here in this properties file. And then we also tell where to scan to find the various elements that we need to make this work. So here's the properties file. As you can see, this defines the properties for the Flight's microservice, which plays the role of a front-end app gateway or API gateway. And it's also a client for Eureka because it's going to be used. It's going to use Eureka to find all the microservices to get registered. The name of the microservice or the API app gateway is Flight. That's the port it listens at. Here's where Eureka is going to be listening by default. And then we also have some things that we say we don't want this to be registered with a Eureka because it's a front-end app gateway, and we don't want it to be part of that particular mechanism. So let's go take a look at the controller. This is where things start to get much more interesting. And so the Spring controller, as you all know from what we looked at before, is the way that clients, remote clients, things like apps or browsers and so on, get access to the services that we have for the flight listing case study. And basically, as you'll see here in a moment, as you probably can guess, the controller defines the mapping between the HTTP requests, the GET and POST and so on, to the various methods that do the work. And as is my tradition, is my style, I have the controller do very little, and it pretty much forwards to an auto-wired service. And we'll see how that works in a second. And the features that are available here are really, really cool because they allow us to do things like asynchronously find all the available flights, asynchronously find the best price for a given flight request, get a list of airports asynchronously, find departure dates for a given pair of airports asynchronously, and so on and so forth. As you can see here, we make this thing a controller, REST controller, and it's also something that we call a cross origin, which is required for Eureka redirection. You'll see how that gets used in a minute. Here's what the actual endpoint methods look like in this particular controller. A lot of this stuff will look familiar from the point of view of the names of the methods, from the point of view of how we identify these things in terms of the HTTP URIs that are being exposed. What differs primarily are the return types from the various endpoint methods we have here. That's where the reactive programming stuff comes in. So we have a get airports method that's going to return the flux of airports. And if you recall our discussion from last class about a flux is a reactive data type. It's part of Project Reactor. It's very similar to an RxJava observable. And what it does is it'll essentially emit the airports as they become available. And that is beneficial, not probably that big of a deal in this case because it doesn't take too long to get the list of airports. But if you had a longer list or you had something that would take a while to get, this will allow us to be able to start streaming the data back to the client without waiting for everything to be contained in a buffer on the server side. And as you can see, all this controller method does is just forward to the get airports method in the service. And we'll look at that in a second. We also have another method called find departure dates, which takes a departure airport as a string and an arrival airport as a string, and it returns a flux of departure dates from the departure airport to the arrival airport. And these come back as local data objects, and those are Java objects. And the flux, again, allows those things to kind of be streamed back asynchronously. And we'll look at the implementation of that shortly. Here's where things get a little bit more interesting. We have two methods that have more or less the same signatures. One is called find flights, and the other is called find best price. And I should probably call this find best price flights, but whatever. And so find flights and find best price flights contain or take parameters that indicate the departure airport, the departure date, the arrival airport, and the currency that you want the results to be given back in. And it goes ahead and forwards to a method in the service called find flights. And then there's also another method that's in the service called find best price flights. And that will go ahead and find the best price for a given departure and arrival tuple. And so we'll see how those implementations are done when we get into the service here in a moment. And then the last couple things that are exposed here, they don't strictly need to be exposed, but I expose them just because they're kind of useful. You could imagine wanting to use this as well as the flight service. There's one that can be used to get rate and then get rates. And we'll talk about that in a second. Before I do that, though, let me just say that find best price and find flights return fluxes of flights. And this is probably where the flux really starts to shine. Because you can imagine it could take a while if you had a large number of airline databases you had to search. It could take a while for all those databases to come back with their flights for that departure airport, that arrival airport on that departure date and so on. And so by using a flux, we don't have to have the client block waiting for everything to come back. As things start coming back in dribs and drabs, the client can take them and start to display them if they so desire. So that's really where the fluxes start to shine. Down here with get rate, you can see that get rate will take a from currency and a to currency, and it'll give you back something called an exchange rate, which is just it's basically a tuple, or it's a record of sorts that will give you the exchange rate for a given pair of currencies. And that comes back as a mono. And a mono is a reactive data type that's part of Project Reactor, which is going to be able to either emit or not, but if it does emit, it just gives you one result. And then finally, the last method we have in our controller is called get rates, and that takes the to currency that we want to go to, and it'll give you back a flux of all the exchange rates that match the to currency. So if you say the currency I want to convert into is US dollars, it'll give you the mappings for all the other currencies as a flux. And once again, as we've seen over and over again, everything goes ahead and just forwards to the corresponding method in the service, which makes it all very clean and removes kind of implementation details from the controller. Again, something else that's worth noting, all of these various constants like rates are defined over here in a helper class called constants. You can see here we have in endpoints like rate and rates and airports and best price flights and flight dates and so on. And then we've also got some other constants that turn out to be useful for other kinds of microservices and things like that we'll take a look at shortly. So that's a quick overview of the flight controller. We're now going to go ahead and turn our attention to the flight service.